All right, let's talk about logs. So grab your calculator. We'd really like you to be putting these numbers in your calculator. So let's say log of 100. Some of you, you'll enter the log, you'll hit the log button and then you'll type in the 100 and then equals. Some of you, you'll put the 100 in and then you hit the log button. So it just depends on your calculator. So, but if you do log of 100, what do you get? Hopefully you get a 2. And let's do this now. Go ahead and do log of 1,000. What do you get? And I'm hoping you get a 3. How about this? Log of 0.01 equals. Give you a moment to try that in your calculator. And I hope you get -2. And log of 0.001 equals, and if you're putting that into your calculator, hopefully you get a -3. So what's going on here? You probably recognize there's 2 zeros, you got a 2, 3 zeros, you got a 3. If you think about it, 2 decimal places, you get the -2. 3 decimal places, you get -3. So something that's implied on your calculator is that this is log base 10 in all these cases. Some of you, in your calculators, you'll actually be able to specify the base, but most of the time it's assumed that this is log base 10. So what it says is 10 raised to some exponent will give me a 100. Let me write that out. What it says is 10 raised to the power of 2 equals 100. So when you push the log button on your calculator, it's going to give you the exponent. Same here. 10 raised to the power of 3 equals 1,000. So these, again, these are all exponents. Every time you push the log button, the results is an exponent. This would be 10 raised to the power of -2, gives you that. This is 10 raised to the power of -3 will give you that. Now, one thing that's going to help us a lot when we start solving logs is to be able to convert between a log form of the equation and the exponential form of the equation. And so this is really just a mapping thing. We're not doing math. So here's your base. Let me grab a different color pen maybe. So here's the base, and it's going to show up right there. And this is what we call the argument. So here's x right there. And again, that's the argument. And then this is the exponent right here. So anytime you hit a log button, the result is an exponent. So the first thing I want you to get comfortable with is taking an equation, whether it's written in exponential form or log form, and I want you to be able to convert it into the other format. So we have exponential, we want to convert it into that. So I'm going to write the word log. And here's the base, right? Base and exponent, so that's a 10. The exponent will go right here. And here's our argument. And let me just kind of highlight that for you. So our 10 is going to go to right there. The exponent will go right there. And then here's our argument will go right there. Now this one is in log form already, so we need to convert it to exponential. So the first thing is, note, there is the base. So I'll just write it out that way. So I have, back here, we're going to try to get to that format. So here's the base. This is the exponent. And then this is the argument right there. So now we put it in that form. And again, you can see that's going to go right there. That goes there. And that goes there. I think I would start off by always writing down the base first. I think it's probably the clearest. You can clearly see that's the base, put it down there. That's the base, put it as the base. And then it's up to you, whatever you think is, do it in the order that works best for you. So that's you're going to have several problems, homework problems, that are just a matter of mapping from one format to the other. So let me erase this board and we'll try some more problems. All right, so you can see I have 3 log equations. And notice here we have log of something, well, and this time it's just flipped around. And it's probably good practice to be able to feel comfortable with the order those are written up there. So we're actually going to solve. Over here we're going to find out the value for x, the value for x, and the value for x. And you can see they're all in different places in the problem. So starting with this one. So the first thing we can do is rewrite this, of course, is in the log format, right? We want to map it over here so it's in the exponential format. So you can see my base is an x, so let's write that out. So I have x. This is an exponent, raised to the power of 3 is equal to 64. So you can see that goes to there, this goes there. So we've just remapped it, just like we did up there. Now the next step is you want to take that 64 and factor it. And so you can imagine that could be 4 times 16, which is 4 times 4. So I can rewrite this as x cubed raised to the power of, equals 4 raised to the power of 3. Since the exponents are the same, the bases have to be the same. So we actually aren't going to get rid of the 3's. And it's not like we're dividing both sides. You could, I guess, take the third root, but really we're just saying if those are the same, these have to be the same. So x equals 4. So again, we're in a log format. We want to rewrite it as an exponential. And so to do that, you can see right away, 2 is our base. Equals, so the equals x part, that's our exponent. And then over here I have 1 over 32. So I've simply gone from log format to exponential form. The next thing, remember over here we factored the 64? Let's factor 32. And that's going to be 2 times 16, 4 times 4, which then gives us 2, 2, 2, 2. So we have 5 2's. So I can rewrite this as 2 raised to the power of x equals 1 over 2 raised to the power of 5, right? Now one more step. You remember the reciprocal of something like that? I can rewrite this as 2 raised to the power of x equals 2 raised to the power of negative 5. Now, using the same thought process we did here, the bases are the same. They're both 2's. That means that the x and the negative 5 must be equal to each other. So there's our answer there. Now, coming over here, our base is x. That's our exponent, negative 3, equals 1 over 125. And 125, we can factor that into 5 times 25, which is 5 and 5. So I can rewrite this as x to the negative 3 equals 1 over 5 to the third. Now if we do the same trick here, we took a fraction and rewrote it with a negative exponent, then you can see I have x to the negative 3 equals 5 to the negative 3. And using the same argument we've been, the exponents are the same, the bases must be the same, so x is equal to 5.